Hi and welcome back. We will now see the pros and cons of using the adapter design pattern. But first, I would like to do a quick recap of the structure of the adapter pattern and also the example that we used while implementing this pattern. This is the structure of the object adapter. The client wants to use the features of the adaptee, but the adaptee has an incompatible interface. So that's why we create an adapter here. The adapter inherits from the target so that it has the same interface that the client expects. The adapter will then compose the adaptee. This means the features of the adaptee are used through composition. That is why this is called as the object adapter. In our example, the game wants to use the features of the accelerometer. But the accelerometer has an incompatible interface. You can see the game depends on these methods, but the accelerometer does not have these methods. So that's why we created this accel_adapter class that inherits from the input class so that it has the same interface that the client expects, but internally accel_adapter uses the features of accelerometer, and it does so by composing accelerometer. So that is why this accel_adapter is the object adapter. This is not the only way through which an adapter can be implemented. The other way we can implement an adapter is using the class adapter. In class adapter, the adapter will inherit from both the target and the adaptee. In our example, we inherited accel_adapter from input and accelerometer class. Now, accel_adapter uses the features of the accelerometer directly because the methods of accelerometer are inherited in accel_adapter. One thing to note here is accel_adapter inherits the interface from input, but it inherits the implementation from accelerometer. One object adapter can work with multiple classes. This is useful when you want to use the features of all the classes in a hierarchy. For example, there could be a hierarchy of classes like this. This may be a base class, and here you have different child classes. And you may want to use the features of all the classes in this hierarchy, but their interface is incompatible with what we need. So it is possible to create one adapter here, and this adapter can adapt to the interface of the base class. So this way, through polymorphism, one adapter can work with all the classes in this hierarchy. The other advantage of using object adapter is that it can always adapt to an existing class. Even if the class is hidden, we can still adapt to it through its base class. Now, some of the disadvantages of object adapter are, first of all, it cannot override adaptee's behavior because we are not using inheritance here. The second thing is that the methods of the adaptee are invoked through pointer indirection. This might not be a big disadvantage, but note that the calls are always made through a pointer. Let's see what are the pros and cons of the class adapter. The calls to the methods of adaptee through the adapter are direct because the methods are inherited in the adapter, so there is no pointer indirection. Because class adapter uses inheritance, it can override adaptee's behavior. This is not possible through object adapter. But this leads to a disadvantage. If the adaptee is a final or sealed class, then you cannot use the class adapter. Final or sealed classes cannot be inherited. Not all languages support multiple class inheritance. So, it may not be possible to implement class adapter in all the languages. And for the same reason, if you want to work with subclasses of adaptees, then it will not be possible to use a class adapter because it will be difficult to inherit from all the adaptees. So when to use this pattern? Use this pattern when you want to use an existing component but that has an incompatible interface. Or you want to use the clauses from an existing hierarchy but they have incompatible interface. In that case, you can use an object adapter. You can also use this pattern when you want to reuse an existing class that has an incompatible interface, but you also want to modify some of its behavior. In that case, you can use the class adapter. So that's all about the adapter design pattern. We have seen the different kinds of adapters that can be implemented. I'm sure you can now decide what kind of adapter to use when you want to reuse an existing class with incompatible interface. In the next section, we will start with the facade design pattern. Until then, goodbye.